any aquifer system, if it's sustainable, would have to have recharge, right? You have to put water into the system as you take water out, otherwise eventually you dry the system up. So it's an incredibly vital resource because there's over 2 million people that depend on it for their water supply. My team, the Aquifer Management Services team, is responsible for our research, our computer modeling, our data collection, and our sustainability programs at the Edwards Aquifer Authority. So recharge is water that enters into the system, and it only occurs on what we call the recharge zone, which is it's a narrow band where the Edwards limestone is exposed across the region, as well as agricultural interest to the west and ranching interest, as well as there's a lot of the springs that provide water to the surface component, like the Guadalupe River. A lot of the research we're doing is really focused on how do we have a higher degree of sustainability in the future, knowing that we're going to continue to see population growth and demand growth on the system. We've been very successful in the modeling realm, for example, being able to make well-informed management decisions about the aquifer using computer-based modeling. Some of our modeling staff has spent a great deal of time downscaling global climate model data, and we'll be using that data to make forecast predictions. I think one of the big challenges that we're looking at is looking into the future as we anticipate perhaps some changes in our climate. So a lot of the modeling indicates that we can expect shorter duration but very intense drought periods, followed by perhaps very intense rainfall events. We need to manage the system in a way based on good science and best available technology that we can sustain spring flows and availability of water through those droughts, as well as not see damage or problems arise from flooding events. You can think of it as 3 buckets, and without those buckets, the aquifer just couldn't function as it does. We have a contributing zone, some people call it a drainage area. That's the largest part of the system, and all the rain that falls in that area. The rain that falls there feeds and charges the surface streams and rivers. They cross the recharge zone. The recharge zone is where water enters the aquifer, where recharge occurs. And then there's the artesian zone, where water is held in the system under pressure, and most of the water withdrawn from the aquifer comes out of the artesian zone. We engage with a lot of other entities through our field research park, as well as a number of our staff members publish on a regular basis. They attend conferences, they present their research and their data. We feed a lot of information to our public outreach team, and they share that with the public. So most of our work is really focused on the science community as well as some of the other agencies. In fact, just yesterday here at our field research park, we had the National Resource Conservation Service come out and talk to them about the work that we're doing here and the different types of land management practices that we're actively researching to see what benefits they might provide to the groundwater system as a whole. The better we can understand how the aquifer works, the better we manage it, the more water can be available to all the users throughout the region. If we can achieve that and we can quantify that with the research, then we can help others to conduct those same kind of practices across the region with a net benefit to everyone.